All right, so yeah, so like I said, let me give you the test information so you know where we're at. So the schedule says we're supposed to do the practice. The next exam goes through the end of chapter 10. So we need to cover 10.2, 10.3, and 10.4, and we haven't finished 10.2 yet. So we're 1 day behind. So so let's push the practice. So basically, here, let me write it right here. So next Tuesday, obviously not today, Tuesday. Next Tuesday, Halloween, the 31st, we'll have the practice exam. Practice exam number 3. And then 2 days later, Thursday, November 2nd, we will have exam number 3. There it is. It's going to be on Halloween. Scary. No. But anyway, there we go. All right. Good. Yeah, Amanda.
Are you going to release the practice exam?
Soon. I know. I've got almost got it done, but it's I've got to just add the E options. Basically, I've made the practice exam and the third exam, but I haven't put in the E options and mixed up the answers. That's all I got left to do. But it takes about an hour to do all that, and really soon. Yeah, just haven't been able to find that hour. So yeah, really soon I will. Any other questions on the exam and all that? All right, let's get back to it. 10.2, talking about the parabola. Parabola. So that's the the U shape, up, down, right, or left. So okay, so on this one we did number 9 last time. Been a long time though, and you didn't have any homework on it. So let me help. Remember what you got to do on this. If you want to graph this thing, which is what they want. They want us to graph it, find the vertex, focus, directrix, everything in the world. You've got to get it in the right form. What do I mean right form? It's got to be like x plus a number, minus a number, whatever, squared is 4a times y plus or minus some number. We got to make it look like that. Do you know what I mean? Are you with me on that? If we have to take that thing they gave me up there and make it look like this. Because what? Why do I got to do that? Because that's the only way we've learned how to graph it. I mean, we can't graph it looking at the way it is in the beginning. We have to get it looking like this. For example, let me just give in some numbers here. If this comes out to be x minus 2 and this comes out to be, y, I don't know, plus 3 or whatever, and this, instead of a, this is, 5 or whatever. So then we'd be able to graph it, wouldn't we? We go, oh, okay, that's what you got. Here we go, I can graph that. What would be the center? If this turned out, that's not what it's going to be, but if that turned out to be the equation, let me make sure you understand that we could then graph it. Could you then graph it? Do you remember how to do this? What would be the center of the U shape? Yeah, do you remember it's the opposite, right, of what's next to x and y? It's the opposite of whatever's in the parentheses next to x and y. That's going to be the case for all these graphs in chapter 10, 10.2, 10.3, 10.4. Hyperbola, parabola, ellipse, all of them. When you got the parentheses, whatever number's in the parentheses next to x or y, the opposite of that is the center of the whatever shape. And today, the parabola. So yeah, so the center of the thing would be what? Opposite of negative 2? Positive 2. Opposite of positive 3? Negative 3. That's the x and the y, the opposite of what's in the parentheses with x and the parentheses with y. For the center. So I'd go, okay, over 2, down 3, there's the center dot. I'd be able to do that if I can make it into that form. And then, which way is the thing going to go? Up, down, right, or left? If it looked like this. You guys, am I confusing you? This is not what it really is, but I'm just showing you if we can get it to look like this, then bang, we can graph it. Which way would it go? Right, left, up, or down? Remember how you determine the direction? That's the most important thing of the parabola. What tells us the direction? Our neighbor's paper. No, not that. Sorry. What tells us the direction? Up, down, right, or left?
The center?
The first power letter, not the second. It doesn't seem like we're clear on that. And today's the day for that. I know you haven't had homework on this yet. So that, if you want to put the number one thing in your mind for parabola, there it is. The number one thing is the first power, because that's what's unique. All these graphs all week, 10.2, 10.3, 10.4, are going to have second power letters. But what the parabola has, uniquely, is a first power letter. See up here? He doesn't have y squared, does he? He has x squared, and regular x, and only regular y. not y squared anywhere. That's unique. That's different. The other graphs are going to have x squared and y squared. All the other graphs are going to have both x squared and y squared. But the parabola has one letter squared, in this case x, and one letter not, y. Sometimes that's reversed, but there's always one squared, one not. Well, so in other words, so I'm saying all that to sink in your mind. The big deal of the parabola is not his second power letter. Everybody's got that. It's the fact that he has one that's only first power. That's what's special about him, and that's what you should really be honing in on. You should be looking over here mainly. That's his special part, and that's the part that tells the direction. What do I mean? So y, what's y? Well, it's up, down. It's not right, left, huh? And which one is it, up or down? Well, if this is positive, y, up. So the first power letter tells. So remember. Well, I'll leave it. Yeah, well, maybe it'll be good. Remember this story? Remember when I did the 4? This is what you want to have in your 3x5 card for sure, is if you have x squared is positive 4ay, that's going up, positive y direction. See, the first power letter is positive. If you have x squared is minus 4ay, then that's a parabola going down, minus y direction, first power letter. If you have y squared is positive 4ax, that's going to the right because positive x direction, first power letter. And if you have y squared is minus 4ax, that's going left because of the minus x direction, minus x to the first power. So it's the first power letter that tells the direction. Most important thing and most difficult thing about a parabola. The other graphs are easier. This is the hardest one, by the way, so that's some good news. Parabola is the hardest. The other two will be easier because you don't have to worry so much about the direction. You get the direction wrong in the parabola, it's ball game over. And that happens to people. So I don't want it to happen to you. So set that in your mind really clearly. What determines the direction is the first power letter on the parabola. So get back to here. We go, okay, positive y to the first. It's going up. So we go, there's the center. It's going up. We basically have the graph. What's the 5? The 5 is how far to the focus point. Anyway, we'll get into that more later. So my point in all that is, this is not the actual equation, but if we can make it look like that, then we can graph it. My iPad is it's behind me a little bit. So after I stop erasing, it's still erasing on my screen. Sorry, it's just entertaining me. All right, so, okay. So we're going to complete the square on this. Have you heard of that from algebra? Remember that, completing the square? So that means we come in here and we say, okay, how do we do it? Does anybody remember? Take that middle number. Yeah, take it over on the side of your paper, put it over 2, and square it. Remember that? You always put the middle. In fact, let me just write it this way. You always put the middle over 2, quantity squared. That will always give you the number you need. So in this case, that's 8 over 2 squared. That's 4 squared. That's 16, isn't it? So what do? Add 16 to both sides.
It's not 16. It's not 16.
Oh, I'm sorry. Yeah, no, I'm totally spacing out. Yeah. I just was dealing with that 8. Yeah, it's 8 squared. It's 64. Thank you. 64 it is.
And the middle number is because it's a variable, a regular number and another variable?
Say that again. It's whatever number's in the middle.
16 and another x, so the 16's in the middle.
Right. It's whatever's with the x to the first power. Yeah, that's what I mean by middle. Am I answering your question?
Yeah.
Yeah. Yeah, it's whatever is with x to the regular x. It's whatever's with the regular x. That's right. Yeah, it's the one in the middle. So take the middle number over 2 squared, so 8 squared, 64. Then you add that to both sides. Now, what will that do? Why are we so into that? Well, that will make these 3 factor, and not just factor, but factor as the exact same thing twice, identical twins. Really? How does x squared plus 16x plus 64 factor? You know, x plus 8, doesn't it? Right? Because they add to be 16 in the middle, and they multiply to be 64. 8 times 8 is 64, and 8 plus 8 is 16. See that? See how it factors the exact same thing twice? What happens on the other side? Well, whatever happens, happens. You just gather like terms. 64 minus 8, what is that, 56? And then this is x plus 8 squared. Do you see how we're giving it that look we need? Right? And what happens on the other side? Factor out the 8. Y plus 7. We good? Now we're almost there. One more thing. Remember, the look we need also has to force a 4 to be there, doesn't it? We have to force a 4 because then we find the A, which is how far from the center to the focus point. We need that. So what number can I put here? Remember, whatever number is originally there, when you force a 4 out, you're multiplying by 4. So vice versa, you got to divide this by 4, which is 2. I mean, this one we can see easy. But that'll always work, right? You just take the number that's there and divide by 4. That's what goes here because you're multiplying by an extra 4. So that's 8. That's still just 8, isn't it? I've just given it a new look. It's a big fancy plastic surgery, removing the wrinkles, so it has the look we need to make it easy for us to graph. That's like half of math, is making things look different so you can do what you need to do with it. That really is, if you get the idea of that. So much of math is that. Okay, so we did it. We transformed the way it looks. Now we can take this and graph. We good to there? So definitely will be one of these on the exam, these completing the square ones. Make sure you know how to do that. Let's graph it now. So x plus 8 squared, okay. Go to a new screen. So, oops. X plus 8 squared is 4 times 2 times what? What was it? Y plus 7. And they want everything in the world on that. Okay. And what numbers is this? Number 16, thank you. So question number 16. Okay, now can you graph it from there? Let me give you a minute. Go ahead and graph it from there. Produce the graph. So start with the center. Start with the middle. What is the center of that graph? The center is opposite, opposite, right? It's always the opposite what's in the parentheses. -8, -7. Good like that. Opposite, opposite. So when you go to the graph, let's see, it's going to go -8, so 1, 2, 3, 4, 5, 6, 7, 8. Down 7. So there's the center of the parabola. It's right there. And is this thing going, well, let me let you determine that next step. Determine if it's going up, down, right, or left. And then what they want is they want the focus point also. See if you can find the coordinates of the focus point. 2 students in my office. I'm for sure going to get sick, I think. I don't feel sick. But I was in a meeting last night for 4 hours in a small room. And at the end, one of the guys said, I just feel terrible. I got a headache in my chest. I'm like, great. 4 hours in this room with you. No, he's my good friend, but I'm done for, I think. All right. So anyway, so there's the center, -8, -7. And which way does this thing go? Up, down, right, or left? It's going up, right? We good with that? How do we know it's going up? First power letter, positive, out in front of it, right? Positive y to the first power. We could have known that way back here. Positive y to the first power. It's going up. We knew that from step 1, right? Positive thing in front of y to the first power. That's all it takes. Positive or negative, first power letter. That tells the story. So it's going up. Okay, great. It's going up. It's going like this. I'll get more specific in a minute, but for now, it's just good to have something to look at. It's going up from this center, up it goes. So, where's the focus? Excuse me. Where's the focus? Excuse me. How far from the center to the focus? That's that right there. That's the A. Is everybody understanding what A represents? A is how far, it says 4, how far center to focus. How far center to focus. That's what that A represents. That's why we force a 4 when we do the parabola equation, because then the number next to it tells us how far from the center to the focus. And the focus is always inside the satellite dish, right? Like the receiver on a satellite dish. So that means it's 2 units, boom, boom, right there. 2 units up, since it's inside and it's 2, right? That's 2 units up. Good? Now what are those coordinates? How do we find those coordinates? Well, you add 2 to the y coordinate, right? Not the x. So that's the easy way to find it. So that'd be minus 8 minus 5. So I'll put that right here. Minus 8 minus 5. That must be the focus. See, I added 2 to the y coordinate. Is that making sense? And I think is that everything they want? Oh, they want the lattice rectum? Do they want what do they want? Let me go back. They want the vertex. We got that. They want the the directrix. The directrix. Okay. Where's the directrix line? It's always behind the parabola. Opposite direction, same distance as the focus. So in other words, let me put this back a little tighter here. When I say minus 7. So it's got to be 1, 2 this way. Does that make sense? So if it's the focus is always inside the satellite dish, the directrix line is a line behind the parabola. Same distance to the other side. So it's 2, if the focus is 2 up, then the directrix line, here's the directrix line, is 2 down. Well, how do you find out exactly where that is? Well, now you subtract 2 from the y coordinates. We're moving up, down. So that'd be what? Minus 9. So that's y. It hits the y-axis at minus 9, right? This is the y-axis. It's y equals minus 9. And we're done. I think. I don't think they want the lattice rectum on this one. Do they? I better go check. What do they want? Oh, wait a minute. That's not the math guy. All right. So I'm going to leave that. Is that okay? Questions on that one? We good? All right. That was a long one. So try that one. So y squared. Move it over here. Minus 4y plus x is minus 5. What are we going to do with that x? Move it to the other side, right? If you noticed in all the equations, we separate the x's and the y's. They're on different sides for the parabola. That'll be different in the next section, 10.3. We're going to keep them all on the same side and put a 1 on the right side. But for now, for the parabola, we separate the x and the y. So just yank this guy over here. Get him out of the way, right? We separate x stuff and y stuff on different sides. It's just the look we give it, which helps us graph. It's all just for our convenience. So take it from there. Find that middle number, use that middle number to find the magic number. So you grab the middle number over on the side, put it over 2 and square it, right? We good? Middle number over 2 squared, which is minus 2 squared, which is 4. By the way, the magic number is always positive because you square it at the end. It's always positive because it's squared at the end. So add 4. But you got to do it to both sides, right? Anything brand new that you bring into an equation, you got to bring it in with balance. Otherwise, you change the equation, right? That plus 4 was not there before. I'm bringing it in brand new. It wasn't part of the original question. So when you bring in something brand new, you got to bring it in with balance, right? The two, if they were equal before, you treat them the same. They're still equal. I added 4 to both sides. All right, can you factor now? Now that left side is guaranteed to factor as identical twins. Same thing twice, so square. Right? That'll make it happen. We're giving it the look we want. And then on the other side, you got to force a 4 to factor out. All right? I would first on this other, you guys get here, this is y minus 2 squared, isn't it? We good? Now, what do you do on the other? You can go slower if you want, if that's too fast. It's y minus 2, which is y minus 2 squared. force a 1 out. A negative, so first off, factor out a negative 1. Because that just naturally factors out, right? You okay with that? If you took that minus 1 and distributed it, it's the same thing, right? Now, force a 4 here, or a minus 4. When I say 4, I mean if it's minus 4. So force a minus 4 times something times x plus 1. You with me? So, whatever the sign, 4 and something, x plus 1. You guys get the idea with the parabola? We force a 4 or minus 4 to be in the front. So first we factor whatever's already there. Yeah, so maybe I should have said that. First you factor whatever's already there, and then you force a 4 or negative 4. So how do you know what goes here? You want to put something here so this is really still just negative 1. Right? We're not changing its actual value, just its look. We're removing the wrinkles, right? So it'll have the look we want without changing the value. So what's going to go here? Yeah, remember you just take whatever, remember the way to do this is to take whatever numbers are, when you force the 4 out, on the forcing 4 step, just divide whatever was there by 4, and that'll tell you what to put there. I mean, other than the sign, you know that that's the right sign. Right, we good that? So whenever you force the 4 out, just take what already was there and divide by 4. Because you're multiplying by 4, so divide by 4, and you haven't changed anything. That, if you multiply that, that's still negative 1, isn't it? It just has the look we want now. The value has not changed. So there we go. Now we can use that thing and we can graph. Can't we? So go ahead and crank out that graph now. Because that's what they're going to ask you for. Find, the focus, the vertex, the directrix, and the picture. So give that a try. Start with the center. Start with the middle of that thing. Good. Y minus 2 squared equals minus 4 times 1/4 times something x plus 1. Good to there? So what's the center? It's opposite. That'll be for all the graphs, right? So do the x first. Negative 1, positive, right? X has to come first, then y? For coordinates, right? So back 1, up 2. Boom, there's the center. That good? Gotta be careful about all those little things. So opposite, x, y, whenever we do coordinates. Okay. Well, most important question on a parabola. Is it going up or down or right or left? Everybody see it? Everybody have an answer in their mind? Can we say it with one voice? Which way is it going? Oh, maybe we're not so confident. Remember, it's shy. It's going left. Everybody see that? How do we know it's going left? Negative. X to the first. Remember, it's the first power letter. It's the first power letter that tells the story. Negative x. We could have known that back here. See? Negative x. Once it was moved to the other side. You see, you got to have it in the right look. You may think, well, originally it was plus. Yeah, but it wasn't in the right position. Right? You have y's on one side, x on the other. So negative x. Negative x to the first power. It's the first power letter that tells you the direction. That is the most important thing about the parabola. You got to get that right, or everything will fall apart on you. Does that make sense on that? Everybody good on that? Anything else I can say to help? It's the first power letter. Negative x. What is the negative x direction? Well, the negative x direction is that away, isn't it? That's the negative, right? The positive x-axis is here, the positive y here, negative y there. Negative x is to the left, isn't it? Is that good? All right. So now, can you find the focus point? Where is the focus point? Well, that has to do with this, the A here. And the A, which is 1/4, is, remember what it is? It's how far center to focus. And then backwards to directrix. That tells you how far from the center one way to the focus, other way to the directrix. So what is it? It's 1/4. So that means if I go this way, 1/4, and I go back 1/4, I'll have my directrix line somewhere right here, and I'll have my focus right there. My focus and my directrix. Directrix is always behind the parabola. Focus is always inside the satellite dish, right? Okay, but exactly what are the coordinates? Yeah, that's a little tricky. Let's do that. So what I would suggest is take the center first off. What's the center? It is -1, +2, and then just mess with his coordinates. That's the easiest way. So the focus is what? Left. So is that affecting the x coordinate or the y coordinate of the center? The x. It's a left-right kind of thing. And it's going what? Left 1/4. So for the focus, it's -1/4 on the x coordinate. It's left 1/4. So it's -1/4 for that. It's +1/4 to get over to the directrix line, isn't it? It's right. So first off, -1/4 on that, what's that going to be? Well, a couple ways you can handle it. You can just use your calculator. -1.25, I think they'll take that, won't they? Decimal, just make that a decimal. 1/4 is 0.25. Right, or you can make it, if they want fractions, you could make it -1 1/4, which is -5/4. Remember how to turn a mixed number into a improper, right? You can just say -1 and -1/4 is -1/4. But maybe I should not do that. I was helping somebody in Offstars yesterday, and he was saying that that they kind of just jump on the Math Excel. This section, when you click on the Help button, they don't really explain all the details. They assume you can just do fractions, and they just jump right from here, boom, all of a sudden to the answer. So let me. I know most, I know you know how to do it in general, but it could be a little rusty. So let me help. So -1 -1/4. How do you do that? You make that -1 4/4, right? You make the 1 4/4. You get a common denominator. Remember when you want to add, subtract fractions, you got to make the denominators the same. So I'm giving you several options on how to handle -5/4 then. Again, I just got that answer several different ways. You can do decimals, but I don't think they take decimals. That's the problem. I don't think they take decimal answers. I think they want fractions. So you're going to have to do the fractions. Everybody good with that? So you just take the -1 and make it 4/4. -4/4. -1 is -5/4. So that's the focus. The focus is -5/4 to, the y coordinate doesn't change. It just moves left. And then what about the directrix? So over here, the directrix, you take the center, which is -1, 2, and you add 1/4. So -1 plus 1/4 is -4/4 plus 1/4 is -3/4 for the x coordinate, isn't it? Everybody good with that? Are we good with all that little fraction stuff? Right, so I took the x coordinate -1 and I added 1/4 for the directrix line because it's to the right 1/4. So that -1 is -4/4 again. You got to get common denominator. Plus 1/4 is -4 plus 1 -3/4. So the directrix line is, which axis does the directrix line go through? Which grid line does it hit? Does it hit the y grid anywhere? Never touches it. Does it hit the x grid? Sure does, right there. So it's x equals -3/4. That's the equation of the directrix line. It goes through the x-axis at -3/4. Good? We okay with all that? That's everything they want? All right, I'll move on. Is it warm in here? A little warm? The stuff in this section now. I think this will be easy. Can you see that picture? So basically they have a parabola there. It's over 3 down. So its center is right here. And then, so it's going through the point over 3 down 1 and of course it also goes to the center is 3 down 1. It's 4, 0 there. So which equation, A, B, C, or D, is the correct one for that parabola? Well, remember, you're supposed to do opposite, you know, from the center to the equation is opposite, huh? So I should see an x minus 3, this is the x coordinate, this is the y, and a y plus 1 in the equations, right? So I should see x minus 3, because that's regular 3, so x minus 3 in the equation is minus 1, so y plus 1 in the equation. So these guys are out. They have y minus 1, they're wrong. It's supposed to be y plus 1 like these guys, y plus 1. So it's one of those two, first off. I'm already down to those two. Good? Just based on the center being opposite, opposite. Good? Now, which of those two is it? Yeah, how do you know right away, Mando?
The center.
Well, they both have the same center.
And the negative switches it.
That's right. This negative right here, what does that do? What does it do? Well, what would that graph look like? Make it go left. That would be negative x to the first power. First power letter tells the direction. That would be left. This thing's going right. It's positive x versus that one. I never even need to use the 4, 0 thing. Just, that's all we need. Center and direction, done. Right? Everybody good with that? Getting the hang. That's the main thing in the parabola. It's all about the direction. Everybody understanding the direction? This thing is going in the positive x direction, isn't it? So positive x to the first power has to be in his equation. And the C here has negative x. This is no, because it has negative x. That would be left. All right. Okay, so, yeah, it's probably hard for you to read all those tiny little words there. Oops. Okay, so let me give you the highlights. Basically, what they're saying is they have a satellite dish. It's shaped like a paraboloid of revolution, which means a big three-dimensional parabola. It's all, you know, it's all that means. Signals, yeah, blah, blah, blah. It's like what I told you about satellite dish. If the dish is 12 feet across, so there's the first fact. 12 feet across at its opening, 4 feet deep at the center. So it's 12 feet across at its opening. It's 12 feet deep at its center. Where is receiver placed? This is exactly what an engineer would calculate. So now that we have this satellite dish, okay, so satellite dish, and it's 12 feet. Well, that's not a very accurate picture. It's oops, I'm just not a very good drawer. It's 12 feet and it's 4 deep. Does that make sense? So 12 feet at its opening, 4 feet deep. Where should they place the receiver? Like, I mean, how far, you know, it's somewhere like here. Should it be like 2 feet or, you know, foot and a, you know, right here, 1.5 feet or 3 feet? Or where should they put the receiver so that all the beams that come in will be aimed? You know, remember we talked about that, right? That the curvature on a satellite, a parabolic curvature is perfect curvature to aim everything right at the focus point. That's how headlights work. That's how satellite dishes work. So so they're basically asking me, where's the focus? They're basically saying, where's the focus? Where do you locate the focus to make that work? Well, how do I find that? What am I going to do? Any thoughts? How do engineers calculate that? You've got the stuff now. Got the equations. 12 feet opening, 4 feet deep. What do you think? Anybody have a thought that they want to share? I'm guessing no. Nothing? Is it just like right here? No, there's no reason that it is. It's probably inside. It's got to be inside. It's not there. Yeah. Do you do you realize this is a hard question unless you use analytic geometry? What am I talking about? If you just try to do this by regular geometry, just like looking at that thing and just going, I don't know, this is some kind of curve and da-da-da, it'd be a super, super hard question. But that's why we have analytic geometry. What is analytic geometry? It's putting algebra with geometry. It's like putting words to music. We're going to take the world of geometry. That's what we're doing. This is a geometry question, basically, right? It's a shape, and where's something on the shape? That's a geometry question. But we're going to answer it by using algebraic equations. In other words, that's called analytic geometry. That's what we're doing here technically, is algebraic geometry. Meaning, I'm going to come in here, and I'm going to make up an axis system. And I'm going to say, let's stick that parabola on a make-believe axis system. An XY axis, a grid system. And turn that parabola exactly sideways. Now, there's not really an axis system there. See why I'm saying make-believe? You don't look at the roof, somebody's roof with their satellite dish up, and go, I see the axis system. There it is. There's no such thing. We're making that up, right? Remember, math is made up? And here we are again, making up math to help us solve things that are real, right? See how math fits in the real world? We're just making up a grid system because then we have equations that will make this question much easier to answer. There's not really a grid system there, but you can imagine one and put it right at the center and say, okay, now this is 12, this is 4, deep in the center like we talked about. So it's on a grid system now. Okay, so if it's on that make-believe axis grid system, and by the way, it doesn't have to be going right. You could have put it going up, going left, going down, whatever. Do whatever you want, right? It's all just made up anyway. You're just putting it on some make-believe grid system anyway. And just whatever you do, I'm just going to go to the right all the time. But you could go up, you know. And then I'm going to make an equation that fits that picture. And once I've got that equation, boom, I find A. Does that make sense? See how the algebra will help the geometry. So, what equation? What's the general equation of a parabola that goes to the right? So remember the direction, positive x direction. It's going to the right. Positive x to the first, huh? So that'll mean the equation is y squared is 4ax. Positive 4ax. You good so far? That's the general look of the equation. Positive x direction. Now my job is just to find A. If I can find A, remember, because what is A? A is how far, you know, wherever, let me get this out of the way, wherever the focus is, this distance from here to here is A, isn't it? And all the way is 4. But however far from the center to the focus point, which is where the receiver, what we're looking for, where the engineers should put the receiver, that is A. That's the role that A plays in those equations. How far from the center to the focus. Okay, so I just need to find A. So how do I do that? I got the equation there. How do I find A? This point right here, what's the coordinates of that dot, which is on the parabola? So it must make the equation true. I could plug it in. And that's what I'm going to do. But careful. How far over, how far up, right? That's what coordinates mean, over and up, don't they? X and Y. So what's the over up to that dot?
4, 6.
Good. 4, 6, because it's up 6, down 6 for 12 total opening. Right? You with me? So that's over 4, up 6, isn't it? That dot is over 4, up 6. And that dot is one of the millions of dots on the parabola. What does that mean when you're on a picture? You make its equation true. That's what a graph is, the picture of all the dots that make it true. So that means if I put in 4 for x, right, this is x, this is y, 4 for x and 6 for y, the equation must be true. Because that dot's on the picture. So that means 6 squared is 4a4. That means 36 is 16a. I just put those 4's together. That's all times, huh? Times. Right? So, bring it over here. So 36 is 16a. Finish solving for a. Divide by 16. And a equals whatever that is. Divide top and bottom, I guess, by 4. What's that? 9/4? There we go. The 9/4, or you can do calculator, what is it, 2.25? Not 2.2, 2.25, 2 1/4. Whatever, that's how far, 2 1/4 feet. So they should put that receiver 2.25, what are we talking, feet from the center. That's where they should put it. And it'll aim everything right at that receiver. That's how they find this. See how we used a made-up axis system that doesn't really exist and algebraic equations to help geometry. That's called analytic geometry. We do it because it's easier. Because geometry straight is hard. But bring some algebra equations in, it makes it a lot easier. Good? Feel like you could do that? There will be one of these on the exam for sure next week. I'll move on. Any questions on that? That good? All right. Or the back. I don't even remember which one I decided, which is great. Keeps me pure, teach you both to the best of my ability. So this one is coming in the back door. It's the same kind of question. You got a searchlight. Searchlight's the same thing, right? It's basically a parabola. They just put the little light source at the focus. That's how headlights work, flashlights. Okay. So you know what I'm going to do? I'm going to put it on a made-up axis system because that helps. I'm going to make up a grid system like all of math, made up, put it on the grid system. I'm going to say there is some focus. See what they're saying here? The light source is 4 feet from the base of this paraboloid of revolution, 3D parabola. So they're saying this is 4. Here, let me make it a little further. They're saying from there to there, from the center to the focus, to the light source. See, you put the light source at the focus, and then the light source shines backwards this way onto the mirrored surface, and it bounces everything straight out. That's how searchlights and headlights work. So you put the lamp right at the focal point, and this is all mirrored parabolic surface. It shines back on the mirror and shoots it straight out. Just runs the satellite dish backwards, basically. All right. So anyway, they're telling me where. So this time they're actually giving me the focus. See how it's the backwards question? They're actually telling me how far to the focal point. There's the focus. That's the A, in other words. The A is 4. They're giving me the A. And what they're not giving me, just a little further here. What they're not giving me is, well, let's talk about what else they are giving me first off. There are, what's the 20? 20 feet is the across. So this is 20. What they're not giving me is how deep it is, right? Yeah, how deep. So they're saying, what's this? How deep is it? That's what they want to know. They're saying 4 feet to the light source, 20 feet opening. How deep is it? So it's a backwards question, isn't it? Can you do that one? Let me give you a second on that. So I'll do one of these two, forwards or backwards, or it could be the bridge one. So start with the equation. Write the basic look of the equation.
Got it. Ouch.
So which direction is this thing going? Positive x. I just made it that way, right? You could make these go up if you want. There's nothing magical about going to the right. The whole axis system is simply made up. It doesn't really exist. It's made up to help us. So positive 4ax, at least the way I put it, it's going to the right. I know the A. The A is 4. Right? They told me that straight out. That's where the lamp source is. So I have y squared is 16x. Good so far? Mm-hmm. So now, find how deep it is. You need the point again. It's all about the point. So what is the coordinates of that point? How far over, how far up? That's what coordinates mean, over and up, right? How far over? I don't know. Call it x. That's what I'm looking for. How far up? 10. Right, because it's up 10, down 10. So you leave x as x, and y is 10. And x is what we're looking for. X is the depth, isn't it? How far over? Now, well, that's the depth. How far up is 10. So I just plug in x for x and 10 for y and solve for x. X will be the depth, won't it? Everybody see that? So easy while the math teacher's doing it. I experienced that too. I'd watch it and I'd go, oh yeah, I got it. Then I'd go home and try my homework and I'd go, what did that teacher do again? When I read this. So you got to try these on your own. You really got to do these on your own. It's a world of difference. I'm prompting you through the right questions, but you need to do that learn to do that for yourself. So we get to here, 100 equals 16x. 100 equals 16x divided by 16. I don't know if they want a calculator. Oh, they want exact answer, they say. So that means just reduce this thing. Divide by 4. Top and bottom. 25 fourths. That, or 6 and a fourth, 6.25. Whatever. All those are good.
No,
Good?
It wants the fraction.
Yeah, I mean, they want the fraction. All's good? Is it wonderful? Not too strong? Questions? All right, so that's how they do this. That's what engineers do. Last parabola equation. This is the hardest section. So it's easier stuff after the, a little easier. I mean, not terribly easier, but a little bit. So we got this bridge thing. And let me make it a little bigger over here. We got this bridge, and they tell me it's a parabolic arc. Parabolic arc. So we got this bridge, parabolic arch. The bridge has a span, S, of 140. You can see in the picture it's kind of tiny, so let me just make it big here for you. They say the total span of the bridge is 140. The max height is 30, which means right in the center it's 30 high, this bridge. Choose a suitable rectangular coordinate system and find the height of the arch at a distance 10, 30, and 50 feet from the center. So I guess that's a bridge over the water. So they're saying, hey, if here's the center, if you go like 10 feet to the right, how high up will the arch be? 10 feet from the right, 30 feet from the right, 50 feet from the center? How high, right? It's getting shorter and shorter and shorter as you go further and further to the right. How much? That's the kind of thing like if they build bridges on a freeway or whatever, they know they need semi-trucks of a certain height to be able to pass through. When the lanes are so much to the right and the left to the center, they calculate this. They don't just build it and hope for the best, of course, right? They calculate with the math ahead of time how high the bridge will be at certain distances from the center, make sure they meet minimum height requirements. So how do they do that? Well, they do what we're about to do. They use parabola equations. So let's do it. So what I'm going to do is put this thing on a made-up, invisible axis system, right? Bridges don't really live on axis systems. We're making it up. So let's come on in here and do this. I'm going to put the axis system there and there. Just put that right at the center. Good? So notice when I do that, you might think, well, yeah, of course, that's exactly how you should do that axis system. I agree. But notice that does not make the center of the parabola the origin. Does everybody see that? Where's the center of the parabola? Right here, which is not the origin. Which is still good. I still think that's the best way to go. But I want to call your attention to that. When I write the equation, when you write right now, please do, the equation for that parabola, the center is not 0, 0.
Makes it a different ballgame.
The center is somewhere else. So go ahead, give that a try. Write the equation now for that parabola. Write the general equation, first off, look at the direction. Which way is that parabola going? Up, down, right, or left? Let that be the first power letter. And think about the center, which is not the origin, and what that will do. Give you a second. Feel free to check with each other, see if you're getting the same thing. How you guys doing? Which way is this thing going? It's going down, right? It's going in the negative y to the first power direction. We good with that? It's going down. Negative y to the first power. So that means it's x squared is minus 4ay to the first power. So far. It's going to be more to it than that, but just getting going. Is that good so far? Does that make sense on that? The most important thing is to get that basic direction thing correct. Negative y to the first power going down. Okay. Now, the center is not 0, 0. If I leave it like that, that would mean the center is 0, 0.
But it's not.
But what's the actual center? Let's write the coordinates right here. What's this point? What's this dot? Remember, over and up. It's over 0, up 30, isn't it? Over 0, up 30. That's the x and the y. We good? That's the center. So then you do opposite. You want opposite. Opposite of 0 is 0. But then the opposite of positive 30 for the y will be y minus 30 to the first power. And x squared will just stay x. I mean, it's x minus 0. So just leave it x. Is everybody okay with that? See about that? See, the center is positive 30 for the y. So I got to make it y minus 30. So this is now a parabola whose center is 0, positive 30. And going down. Negative y direction. Good? So I've fit the equation to the picture. Okay, now, what am I trying to do? Am I trying to find the focus point? Well, that's not really the ultimate question in this one, is it? But we do need it because it's just part of the equation. I've got to have the whole equation. Do you know what that means when they say that to you in a math problem of any kind? When they say to you, find the equation. What that means is find everything other than x and y. Sometimes we use this lingo, and I think sometimes students don't always know. So let me say it as clear as I can. Whenever in a math problem they go, blah, 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 find the equation. What that means is find, whoops, kind of running out of room here. Find everything except except x and y. Notice I got to find a. That's my point. You know what I mean when they say find the equation? You don't want any other letters. You want x and y to. That is the equation. When you have x and y and no other letters, then you have the equation. So in any math class at any time. So yeah, so I got to find a. Before I can actually use that thing, I've got to find a. So how do I find a? Plug in a point, just like we did for the parabola a minute ago. Let's look over here. Do you know the coordinates of that point? What's the coordinates of that point? How far over and up is that point on our make-believe axis system? Over 70, up 0. We good? So if x is 70 and y is 0, that's a point on the picture, on the graph, on the parabola, on the parabolic arch. Right? So that means it makes the equation true. Plug in 70 for x and 0 for y, and the equation has to be true. That will allow me to find, let's make that negative 30, to find a. Do you see that I'll only have a? So first find a. So let me write first find a. So my first job is to find a. So what's this? 4,900 is 120, positive 120a. Two negatives make positive. We good to there so far? How are we doing? Solve for a, divide by 120. Boom. Now, if you divide that in your calculator, it's something ugly, isn't it? I don't want some ugly decimal. I'm going to just leave it, 4,900 over 120. It's easier to have that than some ugly decimal. And plus, I'd have to round. I don't want to round. I'm still in the middle of a problem. It's not a good idea to round in the middle of a problem. So I'm just going to leave 4,900 over 120 for a. So now, do I have the whole equation? Yeah. The equation is x squared is minus 4a. What's a? 4,900 over 120 y minus 30. There is what we mean by the equation, meaning everything but x and y. Right? That's the equation, meaning I can use it now. I can plug in an x, get a y. Plug in a y, get an x. Find any point I want on that graph, now that I have a, now that I have the equation. The equation is the x-y relationship. right? They're related that way. The XY points on this parabola are related according to that equation. All right, so now I can answer the question. You go 10 feet over, how far up are you? They're asking me what? You go over 10, what's your Y? That's what they're saying, huh? When they say, hey, 10 feet to the right, and they're also going to say 30 and 50. If you go 10 feet to the right, how far up is it? Well, that means go over 10, up what? Over 10, up Y. To be at the top of the parabola. So that means plug 10 in for X, Y in for Y, and solve for Y. You'll find your height when X is 10. Make sense? Mm-hmm. So plug in 10 for X. And Y for Y, and solve that equation for Y. So I need to solve that little equation for Y. I'm going to go to a fresh screen if that's okay and solve for Y there. You guys got that copied down? Just plugging in 10 for X, got to solve for Y. What number is this problem? 26. So it's a 10 squared equals minus 4, 4,900. Y minus 30, isn't it? Yeah. Over 120. We all good that? Everybody got that copy down? That okay? So what I did there, I just took the equation. So first I found A, right, by plugging in 70, 0. So I'm just keep using points on the graph. Plugged in 70, 0 to find A. Then once I had A, then I was able to answer their question. Plug in X to be 10, find out what Y is, solve the equation. So this is 100 equals. Now, what do you do with the whole number interacting with a fraction? Put this over 1. Remember all that kind of stuff from your algebra days? 4 goes into 120 30 times. So this is 4,900 over 30, negative I should say, times Y minus 30. Good so far? All is well, right? I just can't cross-canceled there. So what do you do now? I would multiply both sides by, I'm trying to get Y alone, right? Here's the wall. Y saying, I want to be alone. Get rid of all this stuff. So I'm going to multiply by 30 over 4,900 negative. And that'll cancel, 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 cancel. Whatever you do to one side, you get no choice. Same thing to the other. So I'm multiplying both sides by negative, the reciprocal, the upside down. So then how do you do that? Well, the 100, am I going too quick? 100 is over 1. Anytime a whole number interacts with a fraction. So they're going to multiply on the top. 30 times 100, that's 30, add 2 zeros. Over 4,900, it's still negative. And this is just Y minus 30 now. Don't need the parentheses anymore. There's nothing to separate it from. Good to there so far? Got rid of that big chunk. Last step.
And 30 both sides?
Add the 30. So there it is. Y equals 30 minus 3,000 over 4,900. Somebody get that answer? Probably want a decimal. Anybody remember my calculator? That's going to be like 29 point something.
I got 23.8.
I don't think so. Am I thinking wrong? That should be 29 something. 29 point. 29 point what?
39.
29.39? Yeah, let's see what they want. Feet round. So they round to 2 places. Yeah, the height of the arch to, yeah, round to 2 places. 29.39? So there we go. And then same thing. Then they want you to do it all again, because then they say, okay, how far is it at 10 feet? How far is it at 30 feet and 50 feet? So then you got to plug in X is 30, X is 50. Do it all again. 2 more times. A lot of work. Are we good? Does that make sense? Like you could do that on the test?